Hello friends, in this video we are starting with the discussion of the problems from Advanced Math part in SAT, and today we are starting with the problems in nonlinear functions. The first problem will be discussed in this video and the remaining in the coming videos. So stay tuned and subscribe for more such contents. Okay, so let's see the first question. The product of two positive integers is 462. If the first integer is 5 greater than twice the second integer, what is the smallest of the two integers? So basically in this problem, they have given us relation between two integers, specifically two positive integers. It's given that their product is 462 and the first is 5 greater than twice the other. And we are supposed to see the smallest of these two numbers. So let's assign some variables for these integers for setting up equations and having more clarity. So I am taking the first integer as some x and the second integer as y. Also it's given that those two integers are positive, so I can say x and y are greater than 0. So the first condition is the product of these two numbers are 462. So the product is 462, so I can write x times y equal to 462. And then the first integer is 5 greater than twice the second integer. So first integer as we have taken is x. So x is 5 greater than twice the second. So 5 greater than twice y. So 2y plus 5. So I got two equations. xy is equal to 462 and x is equal to 2y plus 5. Now we have to solve between these two equations to get the value of one of the variables and one of the integers, and using either of these two equations and plugging in back we'll get the other value also, and comparing those two we have to identify the smaller and that will be our answer. So let's club these two equations first. You can see in the first equation it's like xy is equal to 462 and in the second equation it's an expression for x. So I am plugging in the expression for x in the second equation to the first equation. So xy equal to 462 becomes 2y plus 5. I am replacing x by 2y plus 5 times y equal to 462. Now let's distribute and simplify this equation. So 2y times y will become 2y squared plus 5 times y equal to 462. Let's rearrange the equation by taking every term to the left side. So I can subtract by 462 throughout. So this becomes 2y squared plus 5y minus 462 equal to 0. So clearly if we solve this equation, we'll get the value of y. So for solving this, you can say it's a quadratic equation. So you can go for factoring or maybe quadratic formula. Any methods can be applied, but in SAT point of view, it would be good to use Desmos. In Desmos, you just have to type this equation and the x-intercept will get you the solution. So it will be the quicker and most advised method because using Desmos effectively is also a strategy for time management and scoring good in SAT. So it's good to do using Desmos, but then I'm just showing you the actual manual method of factoring just for a clarity and a knowledge. So let's see. After that, I'll show you using Desmos also. So here the quadratic is 2y squared plus 5y minus 462 equal to 0. So let's go for AC method. So I'll pick these two numbers, 2 and negative 462. I'll multiply it. So 2 times negative 462. The product is clearly negative 924. Now we'll think about two numbers whose product is negative 924 and sum is 5, so that we can split the middle term and proceed. So you can choose the numbers as negative 28 and 33. So if you add these two numbers, the sum is clearly 5 and the product is negative 924. Using these two numbers, let's split the middle term here and try to factor. So 2y squared, I am rewriting 5y as negative 28y plus 33y minus 462 equal to 0. Now let's group the terms. From the first two terms you can see 2y is common. So I am taking 2y common. to have y minus 14 left here. Similarly, plus I can take out a 33 common from these two numbers, I mean these two terms, and I'll have y minus 14 again here in the second part. This is equal to 0. So clearly we can see the factor y minus 14 is common. I can take it out to have 2y plus 33 remaining. So the factorization is like y minus 14 times 2y plus 33 equal to 0. Okay, so that means by zero product property, you can say y minus 14 equal to 0 and 2y plus 33 equal to 0. That means y is equal to 14 or y is equal to, I can subtract 33 first and then it's like 2y equal to negative 33 and I'll divide 2. So y is equal to negative 33 over 2. But we know that the integers under consideration are positive. So y is equal to negative 33 over 2 is not possible. So we have to choose y is equal to 14. So like one of the integers is y is equal to 14. Now to get the value of x, you can use either of those two equations. I am using the one xy is equal to 462. So y is equal to 14 means this will become x times 14 is equal to 462, and that means x is equal to 462 divided by 14, and you can find this value as 33. So value of x is 33 and value of y is 14. So these two are the integers under consideration here. And the question is asking us about the smallest out of these two integers. That means our answer will be 14. So 14 is the solution for this problem. And for the same thing, as I said, once you get this quadratic, you don't have to do all these factorization in your actual SAT. You can solve this using Desmos. So the graphing part is shown here now. So this is what you get if you are graphing this using Desmos. So you can see I have typed the equation in the checkbox using the variable x. That's how it is usually worked. That's like whatever be the variable in our equation, just replace it by x and type it here. Then you will get the respective graph and the x-intercept will get you the solution. So for 2y squared plus 5y minus 462, I have just replaced y by x and typed the same equation, which is 2x squared plus 5x minus 462. And you can see I have the two x-intercepts. One is negative 16.5 and other is 14. Actually this negative 16.5 is that negative 33 over 2 which we got there. So you can see clearly the positive one is 14. So y is equal to 14, and then using the same xy is equal to 462, you will get the other one as 33. So you can see the difference here. When we were factoring, we had few steps to simplify, but then in Desmos you just have to type that equation, and just with the x-intercept you are getting the value of that particular integer. Okay, so by either ways you will get the smaller one as 14, and always go for Desmos when you are doing SAT. Okay, so that's about this problem. Stay tuned for more such videos. Thank you so much.